Okay. Welcome everyone to Julia Users Helsinki. Pretty exciting version because for the first one we are hybrid, so we got on the line to put a nice movie. And today also double exciting because we have our first external invited speaker. So today we will have Pere talking about Genie. And before giving the floor to Pere, so Julia Helsinki is very informal group of people who are interested about Julia, who live in Helsinki area, and actually don't even need to live in Helsinki area because I don't. So if you can get to Helsinki area and you're interested about Julia, you're welcome. And we meet every month for exchanging ideas, exchanging projects, just simply chatting, having fun. So if you, and this today will also be recorded and end up in YouTube. So for future people who are seeing this in YouTube, if you want to meet us in Helsinki, come and join us. And our speaker today is Pere from the Genie team. And he will talk about the Genie.gl, a framework to build interactive dashboards and websites about Julia. So Pere, the floor is yours.
Thank you, Luca. Thanks everyone for being here today. And yes, so today I will be showing you how to build an interactive dashboard with Genie. And let me start with a quick introduction to what Genie is, who we are, and what we do. Okay, so Genie, besides being an open source package, has recently as well become a company. The Genie story, let me move my window here, okay. Yeah, the story about Genie starts back in 2016 when our technical founder, Adrian Salciano, well, he was looking for a language with high performance and he came across Julia. And given the lack of web development tools in it, since he was a web developer, a full stack web developer, he decided to just create his own framework. And that's how Genie started. Then at the next year at JuliaCon, he introduced Genie to the community. The community liked it and it started growing around it. Then in 2021, Adrian met Cinzia, who is our co-founder, and together they started the company to build commercial tooling around Genie and also support the open source framework. And right now, as of 22-23, we managed to raise some venture capital, and we are a small group of people based in Barcelona, all working towards developing the Genie framework. Now, so this is the core Genie team. From here, we see Adrian, who's a full stack developer with over 20 years of experience. Cinzia, who's an expert in everything that has to do with business, with experience in international companies like DJI. Also, there's Danny, our front-end engineer with also over 20 years of experience. And then there's me, I'm a researcher and I'm in charge of the developer advocacy at Genie. We're also backed by investors in like Speed Invest and Antor, which are one of the most important one in the data space here in Europe. So what does the Genie framework look like in numbers? Well, we have to say that it's the #1 web framework in Julia. Of course, this space is not very crowded in Julia, but still, it's the most popular one. We have over 90K downloads. We also have a very sizable community on Discord with over 700 active members, over 2K stars on GitHub, and many open source contributors. At a glance, the Genie framework looks like this. It is formed by several packages. Of them, the main one is Genie.jl, which is probably the one you might have heard about, which allows you to build full stack applications in Julia. It implements a web server, also features to build your front ends with HTML, features like caching, cookies, form handling, etc. And then built on top of Genie.jl, we have Stipple, which implements a low-code UI layer in order to build interactive web applications. Then we have Searchlight, with which you can connect and work with relational databases, and other first-party plugins that bring features like authorization, API documentation, etc. This is it for the open source stack. On top of this, we have Genie Builder, which is a plugin for VS Code for building your web applications and your user interfaces in a visual manner. And I will talk about this a little bit more later. Now, as a company, what we offer is we have the open source framework to build the web applications in pure Julia. Then on top of this, we have Genie Builder, which makes you more productive in that you don't have to write any lines of HTML or JavaScript. You just have to drag and drop components onto a canvas. And then we also have developed Genie Cloud, which is a platform for the deployment and for building web applications. It is currently in closed beta, so we'll not be showing it today. But yeah, this is something that we are also working on. And yeah, well, we have many users across many industries, and our mission, let's say, would be to make it easier for researchers, data scientists, data analysts to share their work, so that they are able to take their data analysis code, algorithms, scientific code, package it into a web application, and easily share it online with just a link, all without having to learn any web technologies like JavaScript or HTML5 or anything like that. And you might have heard about other tools similar to what Genie offers, like Dash or Shiny. So let me give you a quick summary of how we compare to this. First of all, Genie framework is a full stack framework in which you can build, well, full stack websites involving databases, front-end, interactive apps, etc. We also have the low-code interactive, the low-code API for interactive applications, which would compare to those from Dash Shiny. But as I said, we also add more capabilities with the server and also with the database adapters. We have the no-code plugin for VS Code, which makes it easier to design user interfaces. And also one that is very important, at least for me, is that Genie framework is Julia native from its inception, which makes it sure that it follows all of the guidelines in how Julia applications operate. And this is it for the introduction to Genie. And well, if you would like to talk more about Genie or discuss anything with us, you can join us on our Discord, and we will be glad to help you out if you need help with your projects. Also, if your company is working on something dealing with Genie and you think you will need you would benefit from expert help, then feel free to reach out, and we'll be glad to talk more about it. And yeah, definitely, I just would like you guys to give Genie a try, and if you need any help, please reach out, and we will be more than glad to help you. And this is it for the introduction. Now let's get on with the. Okay, first, before I move on with the, let's say, with the talk, with the workshop, let me give you a few examples of things that can be built with Genie. Okay, first of all, let me ask the audience, how many of you have tried Genie before, building an app? Can you raise your hands, please, if anyone has tried before? Okay, just Luca. Oh, nice. Well, it's okay. That shows that there's interest to learn, and I will be happy, to teach you some. So this is our main site. Here you can find our links to Discord and our documentation site. And I will be showing you now the app gallery, where we have several demos. And these are some of the simple examples that we have for building apps with Genie. For instance, we have one dealing with the differential equations, which is a simulation of the Lorentz equations in real time. You can run it and change the parameters of the differential equations in real time. And it will update the plot. And this is running continuously and synchronously in the background, and you can just change the parameters as it is. As another example, we also have a dashboard for showing the results of applying the k-means algorithm to the iris dataset for clustering of flower types. In this case, it is a regular dashboard where you can browse the dataset, look at some plots, change the algorithm parameters, and also change what's represented in the plots. And this will be more like a data exploration dashboard. Then we have another example for the travel salesman problem, which is a complex optimization problem. Luca told me that there's someone in the audience who might like this this demo. So if you are interested in optimization, this is one example where you have we have a map and we can add cities to the map, well, cities, points, so that we calculate the optimum route through the points. We can also delete points and reset the map. And this is running all of it in real time. And for today, I will be showing how to build the first page of the app that we built for JuliaCon. In JuliaCon, we built a multi-page application with 3 pages, one for exploratory data analysis, another one for the training of a neural network, and another one for an API. In this case, I will be showing how to build this one, and if time allows, I might be showing something else. But let me just see if we go to the ML page. This will be some controls to train a neural network and display the results of the training. And then we also have the API. Which is not loading, but it's okay. I will share the link afterwards and you can check it out on your own. But it's an API where you can make requests to the, now it's loading, sorry. We can make requests to the machine learning model to make new predictions. And it's automatically documented with Swagger, so you don't have to create a documentation page. But as I said, I will be focusing on the first page. And so let me switch to if you are interested in, I mean, I don't expect this to be a long session, but if you would like to after the talk to keep working on this app or giving it a try, there's this GitHub repository at buildwithgenie/Genie workshop, where you can find all of the materials, both the code for this app and also the slides to follow along. So let's go to the slides. Okay. So as I said, I will be showing how to build the first page of this multi-page app for exploratory data analysis of the Boston housing dataset. In this talk, we just introduce how reactive applications are implemented in Genie, and then show how this first page is built. And then at the end, I will show how to deploy it with on Google Cloud Platform. If you would like to learn more, you can visit the documentation website at learn.genieframework.com. We also have a book written by Adrian and Ivo Balbert, which will teach you quite a lot about the building apps with Genie. So let me skip this. Okay, so let me first give a quick introduction to the world of web applications. Well, specifically tailored to the data applications. Now, the workflow when it comes to building data apps can be divided in, let's say, 4 steps, of which the first one is algorithm development, in which we create and refine some data processing routines. Then we do some preliminary result analysis, where we study the results of the algorithms through visualizations or reports, and then fine-tune again the algorithms. Once we are satisfied with the results, we might build an interface around the algorithms in order to make it easier to rerun experiments. We can add things for parameter control, execution reruns, and generate better visualization results. Now, this interface is not necessarily a graphical interface. It can be something as simple as a command line interface or just some scripts to run our code. And finally, we have the deployment, which is making our application, our finished application with its interface available to other users so that they can use it. Since Genie is a full stack web framework, it comes into play into all 4 steps, since it can implement server-side logic to handle databases, interact with web services, or expose routines to other services or to the web through an API. It also, through its low-code UI layer in the stipple package, it provides UI building tools, and also with Genie Builder, it provides web UI building tools to visualize data and interact with the Julia code. And finally, since we are turning our data analysis code into web application, this makes it easier to deploy and distribute to other people just by sharing an URL. Now in this talk, we will focus on the steps 3 and 4. We will assume that we already have some code or some data that we want to build an app around it, and yeah, how to do that. So I will focus on reactive apps. As I said, Genie framework, you can build things like API, static websites, and other types of services. I will focus on reactive applications. A reactive app, in a reactive app, the users interact with it and explore data through several interface elements like text fields, buttons, menus, plots, etc. Now, when a user performs an action on the app, the application responds by executing some code that manipulates the underlying data and reflects these changes back into the user interface. And all of this happens in real time without the need to reload the page. Hence why it is reactive, in that we don't have to submit a request and get the response to the server. It all happens continuously in real time. Here we have an example of a reactive application, which is a simple vowel counter where I type in a message like "Hello Genie," and it will give me the vowel count. As you can see, this happens instantly. The counter is increased every time I press a new letter without any page reload. Now, in order to implement a reactive data app, we have to implement 4 parts. The first one is the data analysis code, which is the code that will be performing the computations and the transformations that process and analyze the data. Then we have the reactive variables, which are a specific type of variables that monitor their own state to watch for changes. And when a change is produced in their values, this is relayed through the application to all of the parts in the application to make sure that everyone stays up to date with the latest value of these reactive variables. Then we have the reactive handlers, which are code snippets that respond to changes in the reactive variables. And finally, we have the user interface components, which are the elements in the browser with which the users interact. These components can be bound to a reactive variable with two-way synchronization so that when a change is made in the UI, the associated reactive variable in the backend will be instantly updated, and the same vice versa. When something changes in the backend, a variable changes in the backend, the associated UI component in the front will be instantly updated. Now, to build a simple reactive application in Genie, I will give you the code. I will show you how to build the vowel counting app in Genie. Here we have 2 files, which is how we usually organize Genie apps. First, we have the app.jl, which holds the logic of the app, and then UI.jl, which holds the user interface. Let me look first at the logic file. We can see that, okay, that first we enclose everything in a module just for better organization and to avoid clashes between namespaces. Then we have import of the Genie framework package. This is a single package which includes everything from the server to the low-code API to build reactive interfaces. Then there's the Genie tools macro call that sets up the development environment with things like hot reloading, etc. After that, we define the data analysis code, which in this case is a simple vowel counter. It could be also imported from a separate file if we want to do so. And then it comes the important part, which is the reactive code. The reactive code is implemented in this block delimited by the app macro. It is important to note that this code is unique to each user. That is, when the user accesses the application, this code is instantaneous so that everyone has their own copy. And when someone performs an action on a component, this does not affect other users. In here, what we have is first the definition of the reactive variables. In this case, an input variable called message to store the message that is typed into the message box. We tag it with in so that it needs to be writable. That means it can be written to from the front end. Then we have an output variable here called vowels, which will display hold the vowel count. In this case, it only needs to be out. I mean, it does not need to be writable, so we tag it with the out macro so that when we change it from the backend, it will show the changes in the front, but it cannot be changed from the browser. And then we implement the reactive handler with the onChange macro. This macro will watch the message variable, the message reactive variable, and when its value changes, it will execute this line of code, which essentially just counts the vowels in the message variable and updates the vowel count. And after the reactive code, we have the page macro, which simply defines a route. That in this case, at the root, it sets with user interface page to load at this specific path. And that's it for the backend code. You can see that we only have more or less 3 macros, in, out, and onChange. And with these 3, you can implement all sorts of interactivity. I would say that it is a pretty clean API that makes it very clear to see what's going on. Then when it comes to the user interface, well, the low-code API provided by the stable package makes it so that you can define your interfaces in pure Julia. In this case, as I showed before, we implemented the UI in a separate file called UI.jl, but you can also write it into a function. So if we want to have everything in the same file, then we can have it. So in this low-code API, we have several function calls that correspond to different HTML and JavaScript components, such as, for instance, text field for an input field, also P for paragraph, serve for a divider, and so many others. When it comes to interactive components, such as the text field, we just need to pass to it the reactive variable we want to bind it to as a symbol. In this case, we pass it the message symbol, and it will be automatically bound to the message variable in the Julia code. Also, we can display the content of reactive variables by using the double mustache syntax. And note that in this syntax, we can also type in JavaScript expressions in case we want to do some more advanced processing, or maybe rounding some numbers or something like that directly in the browser. We also can interpolate Julia expressions. I'm not showing that here, but that's not a reactive. It only works at when the page loads for the first time. And now this is the low-code UI. If you are more inclined towards HTML, you can build your interfaces with HTML as well. As in the end, what the low-code API, what it does is it generates HTML code that is then sent to the browser. So you can skip the low code and go to HTML if you would like to do it that way. Now, in this case, we define the UI components with HTML tags. We bind the interactive components, such as the input text, by using the vmodel directive. And note that these Q components are coming from the Quasar framework, which is a very big library of reactive components. And also, if you come across some example in HTML that you would like to translate to Julia, we also have some helper functions like parse view HTML that will translate HTML to a Julia code. And yeah, besides the low code and the HTML, if you don't want to write any UI code, you can also use Genie Builder, which I will be showing later on. So for now, let me skip this slide. And let's go to the dashboard for exploratory data analysis. As I said, this will be the first page in our app. We will load the Boston housing dataset from a CSV file, show some plots with the statistical information, and then also display the dataset in a table. If you look at the code that's in the GitHub repository I linked to, this is what the folder structure looks like. Okay, so since this is a multi-page application, what we will do is we define a module and the UI file for each page. In this case, the first one, which would be for exploratory data analysis. And then we will have a main entry point with this code where we include each one of the pages. When I do it later on, I will do it a little bit different, but this is how I would go about building a multi-page application. Define each page separately and then include it into a main entry point. In the EDA page, this is what the template looks like. We first import some packages like the Genie framework package, CSV, data frames, and Plotly base for displaying the data. We load the data set. We define a route pointing to the UI file. And what we had to fill in this case, is the reactive code. Then when it comes to the UI file, we only have a header, and we will also be adding the rest of the user interface. To run Genie apps, you can launch them from the REPL. You just need to import the package and call the load app function, and then spin up the server with the app call. And this will start the server, and you can access the page and the app at the port 8000. So the most important part of this first page for exploratory data analysis is plotting. And so let me first talk a little bit about how we use plots and how we do plots in Genie framework. We use Plotly.js for plots, okay? Specifically the Plotly base or the Plotly package from Julia as well. And to create plots with Plotly, it is quite straightforward. You just need to, of course, declare some data and then define two elements. One of them is the trace, which holds the data that will be displayed on the plot. For instance, this will be dots on a scatter plot, like the one we have here in this figure, lines on a plot, etc. We just pass to it the data, and we call the appropriate function, if it's a scatter plot or a histogram or a box plot or anything. Then we would define the layout, which sets the appearance of the plot with things such as title, axis, and other properties. And after we have defined these two objects, we call the plot function with the trace and the layout, and this will show a plot like this one we have here. To use this, to use Plotly in Genie, it's pretty similar. What we do is this: we first, in the UI code, we add a plot by using this low-code call, and this plot takes the trace and the layout as arguments. So then in the backend, what we have to do is declare this trace and layout as reactive variables. This need to be exposed to the UI so that we tag them with the out macro. And as you see, we declare the trace as we did with the Plotly, with the difference that we enclose it into an array. And then for the layout, the same again, same call, except that we prefix it with the Plotly-based.layout prefix in order to avoid clashes with our Genie framework layout. And that's it. After this, a plot will be showing into the web page. So let's now I will go component by component and be showing the code for how to add it to our app. And then in the end, after I have shown all of the individual components, I will do it myself so that you can see what it looks like and how the process works. So let's start with we had three plots. Let's start with the first one, that is the scatter plot. For the scatter plot, we first, we will add the plot within a container, within a div container, so that we can add some headers. In this case, we add a header. We enclose it into a container that will control the width of the plot and so on. And we also have it within another cell container, which is a row, so that all three plots will be side by side. Okay, so in this case, we create this row, and then we add the first plot inside of it. Notice that we have some classes in this UI calls. We can set things like styling and class, etc., by passing arguments to it. For instance, here we have the st classes, which are provided by Genie. In this case, the st call will set a specific width to the columns. Then we have call for, call sm, etc., which are classes provided by Wizard. This behaves exactly like the HTML classes, so if you are familiar with that, this will be the same. And so this is it for the UI code for the scatter plot. As I said, the header, the plot with the trace, and the layout. Then when it comes to the to the code in the backend, what we have to do, we have to declare these traces and this layout. For the trace, we use the scatter call to which we pass the data. We can take it directly from the data frame columns, which we have loaded earlier from the CSV file. Then we can also define attributes like the marker or the label here right in the trace. And then for the layout, in this case, we just set a simple axis title for the X and Y axis. Similarly, for the histogram, we will add the histogram to the user interface, to the UI page, with a call to the plot, with a header. And then when it comes to the reactive code in the backend, we will need to define the histogram trace with a call to the histogram function, passing to it the data that we want to display. Something that I had not said, what we are displaying here is the median value. Like the Boston housing dataset is a dataset with, I don't know, around 13 features. One of them is the median value of houses in Boston, and this is usually the one that we want to target to predict. So in this case, we are exploring how this column in the dataset behaves. So in this case, we want to plot the histogram of the median value of the houses, and we would pass it to the histogram call through its X parameter. And again, we define a layout. And similarly, for the box plot, we add a third plot and declare the trace for the box plot with the box call, pass to it some data, and the same for the layout. Let me just do the plots first, and then I will do the table so that we can see what the plots will look like first. So if I go to a terminal and I open a Julia REPL, okay, now this is what the code looked like. This is the template I showed before, but now I have all the code fill in, except that it's commented out. Okay, here I have it is slightly different from what I showed in the case that I'm doing everything in a single file. Here I call it app.jl, and then I include the UI code from this EVA underscore UI file, okay, which you can see is, again, what I showed in the template with some code already filled in. So if we go to the REPL, we launch the app. With these comments. And as you see here, we have the development environment that is active. This enables features like hot code reloading. When we deploy it online, it will be production instead of development, so that it disables some features. And you see, a new server has been started at port 8000. So if I go back to the browser and open localhost, the first load, of course, this is Julia, so it needs to compile. So the first text takes a little bit of time. Okay, but we can see our page with the header and our build with Genie logo. So now what we have to do is we go to the UI code and we add the UI components. This would be first the scatter plot with the header. Like as I said before, we have a row container here, and inside of it we will add the 3 plots. Here we have another container, which will be a column inside of this row with a header inside of it and the plot. We also add the histogram plot and as well the box plot. We hit save. We will see in the REPL that Genie automatically reloads our app so that we can see the changes in the browser. Of course, this does not show any data yet because we have not defined the reactive variables for these plots. So we go back to the Julia code and simply define the reactive variables. In this case, the out variables for the scatter trace and the scatter layout. Likewise for the histogram, and likewise for the box plot. Here. It's reloading. And now we have our data displayed in all three plots. If anyone has any question, feel free to interrupt me and ask. Okay, it's even if we are remote, it's perfectly okay. But I hope everything is clear for now. So this would be it for the three plots. As you can see, these are interactive plots built with Plotly, and you can go further and customize them even more. This is the default aspect. So let's continue with adding the data table to our application. Now for the data table, what we have is for the UI component, we use, again, we will add a new row, and within it, we will add a new cell with a header and the data table itself. In this case, this table function needs to be prefixed by the Genie framework name in order to avoid conflicts with other Plotly-based components. So to this function, we pass the data and also pagination if we want to have multiple pages in our table. As you can see, since these are simple names, this means that these are reactive variables that need to be defined in the backend. Then there's also other parameters like setting the dense food means that the rows are more tied together and so on. And we can also add many other parameters that are available in the Quasar framework. So for this data table, we define the housing data variable, which simply takes a data frame. This is the data frame that we have loaded from the CSV file and converts it to a data table object. Now this is necessary because this data table object type is provided by Genie. It is instantiated from a data frame, and it adds some fields like data columns and rows that are necessary in the front end. Then for the pagination, we just define a data pagination object and detail the number of rows we want to have for every page of the table. And so let's go back to the code and add this data table to our application. In the UI, we first add a new row, and then the UI component for the table with a header and also a cell container. If we go back to the app. Okay, it would not show anything because in this case, it needs the reactive variables to be defined. So let me just do that. Okay, and now we see our data table here displayed, where we can see that the pagination shows 10 records per page. We can change it to 50 or even show all of them. And this is just one configuration of data table. We can also add things like click events, so that if we click a specific row, we can trigger an event in the back. And the same goes for plots. We can add events to the plots, so that if we select a specific point, something will happen in the back or something will be updated somewhere else in the application, etc. We have examples for all of this in our documentation, so feel free to look through it. And so this is how to build applications using the low-code API. So the process, I hope is clear enough. You load your data, your data analysis code, you define the UI, design the UI with in pure Julia with the low-code API, and then you define the corresponding reactive variables in the backend. So now I will show you how to do all of this using Genie Builder. I mean, not all of this, just the UI part using Genie Builder. And we will also add some interactivity with a slider here on the top. So let me switch to VS Code. Okay, here you see the same application in VS Code, where we have in the main window, we have the no-code editor from Genie Builder. Genie Builder is, as I said, an extension for VS Code. You can install it from the marketplace. And Well, this is the version I'm showing today. We are working on a new version that will be released in the coming months. Okay, so feel free to try this one. And if you come into any issues, like it's in development, it's can be a little bit rough around the edges for some cases, but for building apps like the one we are building today, it's perfectly fine. And as I said, we are working on a new version. I will be showing a sneak peek of that later on. But now, let me show how to build our app with Genie Builder. So here we have our view. We have a Genie Apps tab where we have loaded this multi-page application. In this case, it is the complete app, like the finished app with all of the pages. And we can see that we have each one of the pages, in this case, the EDA, another one for the machine learning model, and another one for the API, okay? And we have the main entry point where we are including each one of these pages. So if we look at the EDA page, here we have the code that I just showed earlier, how to include. If the text is too small, let me make it this a little bigger. And for the, if we see here in the left, that we have access to the pages in our application. Like we have different tabs, one for the EDA route and another one for the ML, which in this case is the one for the training of a neural network. So if we go here and we click on the pencil button, we see the code for this for the UI for this specific page. In this case, it's HTML, since Genie Builder works with HTML. And we can open the no-code editor by clicking the eye icon. And here we have the no-code editor with a list of components to the right, and also other tabs to allow us to change styling of components, see the source code, etc. So let me show you how to recreate our app very quickly. First, we will add, this is, let me make that font smaller. Okay. First, we will add a new row with 3 columns for the plots, and then a row for the table. In these in these slots for the first row, we will add plots. In this case, I add a scatter plot everywhere because the type of plot is configured in the backend through a plot.js. And then we add a data table, which is right here. Here we can, oh, sorry, no, not this kind of table. Sorry, again, data table, this one. Yeah. Okay, we hit save. We can edit the text right here in the canvas. Like I can say a scatter plot here, histogram box plot, and the same for it. And once we are done designing the interface, we can preview it. Well, we can preview it while we are designing it as well. Okay, by clicking on this monitor button right here, that will open a preview in a split window. If you want to make it bigger, you just drag it onto the top bar and we see our UI again. So now, after we have designed the UI, what would come would be going back to the Julia code, define the reactive variables, which in this case are already defined. So let me go back to the no-code editor and bind each one of these components to a reactive variable. So for the scatter plot, we choose the scatter trace and the scatter layout. Same for the histogram trace, histogram layout, and same for the box plot, box trace, and box layout. Now for the data table, we will bind it to the housing data data. Recall that I said that this has additional fields, so we need to target those additional fields. We also need to set the columns. Yeah. And this is it. Now, if we go back to the preview, we have our data already shown. And let's say we would like to add some interactive components, such as a slider, to filter the data that is shown in the plots. For this, we will add a range slider that we can grab from, let me see. The new version will have a search function, so it's easier to find components. Yep, we have the range slider here. And for it, we need to define some additional logic. So we go back to the Julia code. And what we do is, what we want to this slider to do is to filter the data. So what we need to do is first define a variable for the filtered data. In this case, we initialize it to a type of data frame, then a variable to hold the range that has been selected in the slider. And then we add a reactive handler that will be executed whenever this range changes. Inside of this handler, what we do is we filter the data. That is, we filter the data so that it lies in a range between the two values that are selected. In this case, what we filter is the median value column from the table. And we update the plots by passing to it this new filter data as the data to be plotted. And as I said, this will be executed anytime the range slider changes. So if we hit save and we go back to the preview, let me also set, because you can also configure components and add things like, for instance, here label always, so that it shows the selected values. Yeah, well, it does not appear here. Okay. You see, now when we change the selected range here, it appears that I'm running into a little bit of a hiccup. Oh yeah, so I know why I didn't bind the component to the reactive variable, of course. So yeah, now what I need to do is bind the range to its reactive variable that will hold its state, so that when I change it in the front, it will also change in the back. And now you can see that the data changes anytime I touch the slider. We can make it disappear if we change, we set the range that's too large, or we can go back to all of the data. And yeah, this is just a quick example of some interactivity. We can, as I said, you can add all sorts of interactivity. And the good thing about the no-code editor is that you can do this all visually, because designing web pages can be a little bit cumbersome. So hopefully this helps set the layout at least and add the components, and also discover properties from all the components, because as you see, there is a lot of them. Now this is the current version that we have. So let me show you. Okay, now I will show you the version that we are working on, and after that I will show you how we deploy Genie apps. Okay, so let me fire up the video that Danny, our front-end engineer, has recorded for us. I don't know if this will play actually through your audio, probably not. So can you hear the audio? No, right? No. Okay, so yeah, I will talk over it. So in that, yeah, this is the new version, and as you can see, it's what you see is what you get editor. In the version that I just showed, you only saw placeholders for the UI components. Here we have, we can display the plots, sliders, radio buttons, etc. You also have a new plots editor, so that you can change the styling of your plots right there in the UI. And this will also be offered as a VS Code plugin, okay? But you can also execute it independently from VS Code, so you can launch it from the browser without VS Code. And yeah, we also have some new things like improved log browser. I mean, it's a pity that you cannot hear Danny talk about it, because he did a very good job, but sorry about that. And yes, you can see it has a much modern look, and hopefully it will help everyone build web applications up to 10 or more times faster than right now. As I said, this will be available in the coming months. So please, stay tuned. If you want to stay up to date with its developments, we have a mailing list. You can sign up for it on genieframework.com. And let me just now continue with the last part on how to deploy a Genie app. As you can see in the workshop slides, there's much more content on how to build your pages, even the API, or adding the navigation bar. But here we will switch to a deployment. Okay. To deploy Genie apps, our recommended way is through containers. Okay, so let me just say a few words about the containers. Now, containerization is a lightweight form of virtualization that what it does, it encapsulates applications with its dependencies so that it can run standalone in an executable package. Some of its benefits are the application is isolated since it runs in its own environment with its specific dependencies, avoiding conflicts with other software running on the same machine. It's also portable in that the container has everything it needs to run so that you can deploy it anywhere where this container can be run. It is also scalable. Let's say our app cannot handle the number of requests that it's receiving, or the processing of the data is very resource intensive. You can spawn more replicas of the container in order to handle this increased load. And then deployment efficiency, because it solves the typical problem that, well, it runs on my machine, so it should run on yours as well. In this case, this is true since we are using the same container everywhere. To deploy Genie apps, as I said, our recommended way is to package it into a container and put it on a web platform. For that, we recommend Docker, which makes it pretty easy through its Docker file blueprint files. And you can also have more advanced workflows with Docker in that you can include other services like databases and other services that you can think of, all in the same image and running in the same container. Another thing to take into account is that Julia is a little bit memory intensive, so that deployed applications require more resources compared to other things like, I don't know, Python or JavaScript or other technologies. This is the Docker file that we provide to build containers around the Genie apps. It has many lines that set up the system, but out of all of these lines, the most important ones are this one that will install all of the packages that are in the project.toml file. It installs them, instantiates, and then precompiles the packages to accelerate the startup of the app the next time we run the container. Then we also have this early bind parameter, which is very important to set in platforms, in some platforms, because Julia apps take a long time to start up. And if the platform does not detect that our app is listing on a port, it will shut down the container. So this is a very important parameter. And then we have the entry point, which simply executes Julia and launches the Genie app, as I showed before, from the REPL. And yeah, with this Docker file, what we have to do is we place it at the root of the application folder. We build the image with this Docker command, and we tag it with name. And if we want to run it locally, we can spawn the container with a Docker run, assigning it a port. In this case, 8000 is the default port for Genie apps, and we will bind it to the 8000 on the local machine. And we launch this application in this way, and we can access it from the browser at localhost. Now to deploy this container, once it has been created, once we have created the image, there's a plethora of services to deploy applications, like we can use AWS, Flight.io, Heroku, etc. Out of this, the one that I like the most is Google Cloud Run, which is a serverless service for running Docker containers. By serverless, it means that you don't need to manage virtual servers, so that you can just send the Docker file or the Docker image, and it will be automatically deployed wherever Google sees fit. Now, to deploy here, you just need to sign up for an account, create a new project on the web interface, and then perform these steps. First, place the Docker file at the root of the folder, and then you build and deploy the container with a single line, which is this one, okay, which will set the resource. In this case, we set 2 GB and 2 CPUs for our application. And then the terminal will guide us through a few more steps to select zones, etc. So let me show you how this would look like. Yeah, so I run this command here. I give the application a name. In this case, it's Genie Workshop. And I choose a zone. In this case, I will deploy to Europe Southwest. I allow it unauthenticated access, and that's it. It will build the image on Google servers, deploy it, and once it's done with the deployment, it will give us a link here so that we can access our application. We go to the Google Cloud console. We can see here we have our deployed application, and we can access things like logs and other metrics. But this is, as you can see, this is the URL where we have deployed, which is automatically generated. And here we have the logs from our app. And yeah, this is it for the deploying apps. I believe this is a simple workflow, or you can always get more complicated, but for simple web applications, this is more than enough. And it is what we are using right now for our demos. And so I believe that this was this was the last slide. With this, we have finished the implementation of a dashboard with Genie framework, finishing with the deployment. And yeah, if you that's it for me. So if you have any questions, anything that you would like to comment, please do make it so.
Yep. Thank you for the nice talk.
Thank you.
I'm gonna get the noisy clapping with only online.
Like just
No, I didn't hear anything. Yeah.
Yeah. Oh.
yeah.
Any questions? Yeah.
I want to know if you can plot a Gantt chart with Genie.
Did you hear?
If I can launch charts.
Plot Gantt charts.
Oh, well, it depends on what's supported in Plotly. Like we use Plotly.js. So if Plotly supports those, I don't know if it supports Gantt charts, but yeah, if it supports that kind of chart, like as I showed before, it supports maps, for instance, with Mapbox. So there's probably integration for that. So we will have to look into it. I have not come across this use case. Keep in mind that you can also integrate other third-party JavaScript libraries. So for instance, there's D3, which includes other types of visualization. So if there is something else that you need, you can always include it as a regular library like you would do in a normal web page. But for the specific question of Gantt charts, I don't know yet. So I will check it out.
This is somewhat related, but can we use non-plotly plots, for example, plots.jl?
Yeah, well, we can use, no, not directly. Like the thing is that the plots need to be rendered in the browser. So the plots engine needs to be able to somehow translate the plot object into something that can be displayed on a browser, right? So for plots, we have a helper function that will take the traces from a plot defined with plots and turn it into a Plotly.js plot. But you cannot use plots directly. One thing you could do though is generate the plot as an image and display it on the page. In this case, it would not be interactive, but you can always display plots that way through an image.
Okay, and I'm not a web person, but I assume you can use web GPU or Canvas or JavaScript in general.
Sorry, can you repeat again?
So the question is if you can use web GPU or Canvas or JavaScript in general with
You can use JavaScript in general. Like you can place any JavaScript files you would like to include into your project. Like there's the public folder, and inside of it you can put any CSS, JavaScript, anything. Like I have not played with it extensively, but for instance, we have added things like D3 support or Tailwind CSS or support for instance highlighting by just inserting the JavaScript files from with a link in the body or in the header or in this public folder. So yeah, there's potential to add.
Okay.
Other questions?
I'm still sharing my screen. Yeah, right.
Yes, we see.
Let me stop sharing. Yeah, let me stop sharing.
So about the plotting stuff, but actually connected to the previous questions, like if I have like custom data structures in my library, then I would define like a plotting recipe with plot recipes.gl. Like
Yes.
display, like for example, if I define like I don't know some geometric primitives or some sets like structures, or if I have like algorithm and want to visualize a hierarchically algorithm.
Yes.
So can I reuse, for example, if I write the plotting recipes with the normal like plotting recipes.gl, can I reuse that recipes for Genie, or do I need some intermediate steps, or do I need to rewrite the whole plotting logic?
That is a very good question, and one that we have come across many times. And this is something that I'm working on currently, to come up with a workflow to reuse components so that you don't have to redefine the logic and the UI every time. We still have not, we are still in discussions on how to go about it, but let me show you, let me see if I, yeah, let me share my screen again. Okay, you can see my screen, right?
Yep.
Yeah, so here, for instance, we have this app in which I put into practice what you just mentioned, in that this is a gallery. It's not public yet, but I will make it public this week. Yeah, for different configurations of components. And the idea is that you define a specific component configuration, which some colors, actions, etc., so that you can just reuse that. And in this case, we are, what I did, I tried to implement this sort of logic that you mentioned, in which I would define a component with its user interface, reactive variables, and handlers, all in the same structure. And then you can just plug this structure into your page with a simple call. So to answer your question, we are working on a streamlined workflow for that. And hopefully in the next 2-3 weeks, we will announce, we'll publish a guide or give more information on how to do this. But yeah, it's definitely possible, and we just need to get it right so that people can build the component libraries on top of this feature.
Cool. Any question? About the planning stuff, do you have like a rule of thumb how to choose how much memory you need for your app?
Sorry, you have a?
When you deploy your app, like as you showed from like the terminal, you took like 2048 megabytes, I thought, this memory. Do you have like rule of thumb of how much memory to use?
Oh yeah, how much memory is used? Well, I don't know. I'm always setting it to 2 gigabytes, but it's probably less than that. Let me see. I can check it right now. So, for instance, this multi-page application, it's using 800 megabytes.
Oh.
The deployed version is using 800 megabytes. I set it to 2 gigabytes because when it starts up, it needs more memory, and especially on services like Google Cloud Run, if you set the memory too low, it will kill the application because it runs out of memory. So in this case, it's better to be safe. But you can always set a minimum requirements, maximum requirements, and so that let it adapt to whatever it needs.
Okay.
Oh, I have a quick one about community. Do you know, can you hear me from here?
Yeah, yes, very well.
Hi, Fabrice. Yeah, I was just wondering, have you guys been in contact with people that have been working with optimization models and using Genie to I would guess that there is a lot of value in that for interfaces, like to generate interfaces for optimization model. Do you have any contacts with people doing that?
Yeah, there is Benoit from the Jump organization, like he works
Yeah.
for them, and he attended our workshop in Julia Con, and he's also has submitted a couple of PR. Actually, this thing that I mentioned about exporting plots traces to plot.js, he's the one that contributed this function. So yeah, he's interested in Genie. I don't know if he's using it actively, but I know he's played with it and he's learning about it.
Yeah, because
And I definitely think it's would be a good use, like for the Jump
Yeah.
packages and all these people. It's
yeah, it's the last bit missing in
I know Benoit, so I can put you in contact.
Oh, excellent. Yeah, I definitely wanna ask about it because that's kind of relates with Luana's questions in there. Because we work with optimization models and then visualizing and validating could really help, used having a easy to put together interface to understand.
yeah, I see that this is a common use case because even in the documentation for Jump, I see that there's I saw that there was a page for serving models.
Yeah,
And I was thinking that we could do this in Genie as well. So
Yeah.
yeah, it's definitely we need, like the example I showed with the map for the traveling salesman problem. We could definitely do more.
there's a bunch of companies making a lot of money just basically being the combination of both, like AIM scams and the likes. Yeah, really cool. Well done. It's a really cool work overall.
Thank you.
Other questions? Yeah, so thank you, Pere, again for the talk.
Yeah, thank you so much.
I'll bring you.
Thank you. Thank you, Luca, for inviting me to give this talk. It's been a pleasure. Thank you all for attending, and I hope you give Genie a try. And as I said, if you need any help, please join our Discord. We are happy to help on our forum and anything else.
Yes, I'll bring you a Julia Users Helsinki sticker to Anko.
Yes. Please bring more.
All right.
Okay, guys.
All right.
Thank you.
Bye.
Bye.